the velocity problem. What is the velocity problem? Suppose that a ball is dropped from the upper observation deck of the CN Tower in Toronto, 450 meters above the ground. Find the velocity of the ball after 5 seconds. Okay. Now let's understand this. Through experiments carried out 4 centuries ago, Galileo discovered that the distance fallen by any freely falling body is proportional to the square of the time it has been falling. Okay? Do you understand that? That is, longer it falls, it covers greater distance, you see. What this means is if the distance fallen after t seconds is denoted by s of t and measured in meters, then Galileo's law is expressed by the equation s of t equals 4.9 t squared. As time increases, you are actually directly proportional to the square of the time. Okay. The difficulty in finding the velocity after 5 seconds is that we are dealing with a single instance of time t equals 5. So velocity means speed. Speed means distance over time, time taken. But at a certain time, at a fixed time, you don't have an interval of time taken, you see. So this is like the tangent problem. You have only one point. You don't have 2 points. Average velocity is change in position over time elapsed, time difference. So suppose you are looking at time 5 seconds to 5.1 seconds. So distance at 5.1 minus distance at 5 over the difference 0.1. So distance is a square formula. So you found average velocity from 5 seconds to 5.1 seconds. Now you have 2 different times. You use the slope formula, y2 minus y1 over x2 minus x1. And you got this. All right. So what happens if I get even closer? Right? So I'm getting closer. So starting from 6, or you go closer to 5 at 5.1, or even closer, 5.05, or even closer, or even closer. Well, find the different velocities. Look at the velocities. 53.9, 49.49. Oh, it's reducing. It's reducing. It's even reducing. Looks like I'm going to aim towards 49. Okay. That is the instantaneous velocity. It appears that as we shorten the time period, the average velocity is becoming closer to 49 meters per second. So instantaneous velocity means at one particular time, instant. So the instantaneous velocity is defined to be the limiting value of these average velocities over shorter and shorter time periods, starting at 5. So it appears from our calculation that the instantaneous velocity after 5 seconds is v equals 49 meters per second. Okay, so this is an example of the velocity problem. Now next videos I will cover problems from web work on this particular section 1 4 from Stewart's calculus book. All right, until next video then, bye.